Hello and welcome to another episode of Rustacean Station. I'm your host, Alan Wyma. Today I'm with Martin Loncaric. He is the creator of Pancake DB, which is all about simple and cheap event ingestions. So, what does it actually mean? I don't know. That's why he's here. And yeah, why don't you go ahead and start to introduce, yourself and talk a little bit more about Pancake DB for us?
Thanks, Alan. Glad to be here. So, I'm Martin. I've been in various types of software engineering for an industry for 6 or 7 years now. I've done a lot of data engineering, worked with Spark a lot, done a lot of machine learning engineering across all sorts of subdomains, like everything from sort of traditional machine learning, hidden Markov models to deep neural nets on images. But I got really interested in this particular data engineering task that I've seen a lot of companies struggle with, which is how do you take in a stream of data, like one event at a time, and make that easily available to batch processing systems or ad hoc queries that like to run on nicely compacted columnar formats where they can read in millions of rows very quickly. And that's what PancakeDB is meant to solve.
Now, when you say columnar, does that mean that it has to have a schema, right?
Yes. So the schema can be set up pretty easily. In the future, I plan to have more tools for that, like set up your schema from IDL, like from protobuf definitions or something like that you're probably already using.
Okay, so how do you mostly interact with this database? Because I did see on the first page you have a curl command. Is it all REST or is there, because I did also see something spark.sql. Does that mean that you can actually use this where it can communicate the same way you can with Spark? Or how would I communicate with this database?
Yeah, so it is all REST right now. I might allow gRPC in the future because I built it with protobufs. There is a Spark connector, as you mentioned, and the Spark connector just uses the same API that everything else uses. But yeah, as you would expect, that means that you can query PancakeDB tables as if they're any other table that you might read in Spark.
Okay, but the primary way to connect would be over REST.
There's the writing side and there's the reading side. So maybe we want to back up a bit and talk more about what event ingestion is. Maybe the best way to think of it as just a compactor. So you're taking in one piece of data at a time, and you output these compressed formats. So that means that the write side is very simple. You can just write one JSON blob, and this can be human readable. There's no real performance consideration in minimizing the packet size. On the read side, it gets very complicated. So when you read, you're reading something very complicated. It's a compressed stream of data that's not human interpretable. So that means when you write, you're going to use this REST API, probably with a client for whichever language you're using. And when you read, you want to use a bigger tool like Spark, or in the future, probably Presto or Trino.
So what was the last thing you mentioned? REST over Arduino? Did I hear that right?
No, Spark, or in the future, Presto or Trino.
Oh, what is Presto or Trino?
Those are other execution engines that you can run queries on. So in the data platform space, you usually store your data in a data lake like S3 or in the Google or Azure equivalent. And then you have a separate query processing engine where you can run a SQL query. So the data lake itself has no idea how to run a query. It just knows how to serve data.
Okay. I'm still a complete novice when it comes to topics like big data and all that. So I apologize if I'm asking some very simple questions, but I'm sure I'm not the only one out there.
Completely understandable. Yeah. It's definitely a communication challenge for anyone outside the space, but I think there's interesting morsels we can dig into about the Rust side of building this database.
When you say I think you used the term event ingestion, right? Is that any way related to event sourcing where there's just the kind of things happening, or are these kind of two completely different topics?
I'm not sure I've heard the term event sourcing, but for instance, an event might be a purchase event. So if you run an online store as the canonical example, one instance of an event might be a JSON blob containing a user ID, a purchase amount in cents, and a timestamp.
It sounds very similar to event sourcing. So event sourcing is kind of similar where you have kind of a state that just keeps kind of getting updated, right? So if you take a look at your bank account, you have credits and debits constantly happening. And then once you sum up or reduce these events down to a single number, then you would say, okay, this is your balance. So that's kind of a little bit of a short example of what would be a kind of a common use of event sourcing is like you're constantly paying or receiving money. But if you take all those events of those credits and debits and sum them together, that would be your current state. It's really helpful when you can like take a look to see, if this happened, if that happened, what's your kind of final state. But sounds similar, but maybe I don't have enough knowledge to really say this is exactly the same, but sounds similar.
Yeah, it definitely sounds similar, at least in the sense that you've broken down the state of the world into immutable events that happen one at a time, and you can derive the state from that sequence of immutable events.
Now, what I find quite interesting is that you're comparing Pancake to two other pieces of technology, CSV, which I'm sure must be the simple CSV that we always kind of work with, and also Snappy Parquet. Like, what are you meaning by this? Like, is it that it's too slow to actually write to these formats compared to Pancake? Or what are you trying to compare about?
So I'm comparing in particular, so CSV and Parquet are not databases. I'm comparing the internal data format that Pancake DB uses to CSV and Parquet. And so CSV, you can actually write incrementally to it. So you can write like one new row at a time. But the challenge is then when you want to read the data back, if I want to select, the cents amount from all historical purchases, you have to read every single row. You can't just read that one column. You have to read the whole file. And plus, CSV is pretty verbose. So it's storing like numbers in ASCII, and well, you can compress it, but by default, each like data type is using more space than it needs. And Parquet is quite similar to the Pancake underlying data format. But the difference is that in Pancake, we can more easily like append rows one at a time or compact into this Pancake data format.
Now, where does this idea to start working on Pancake DB come from, right? Is it from just a general kind of looking at current solutions out there and saying, this is just not good enough, or at least not good enough for your own solution, or kind of where did the idea come from? Because this is quite an undertaking, right?
Yeah, so I've been working on it 7 or 8 months now. And the reason is that I saw this, all 3 of the previous companies that I worked at, and all 3 of them had come up with a different acceptable solution to the problem. But my thinking is every company is making one of these. Like, why don't we just build the best possible thing so that everyone can reuse it?
Yeah, but if every company's making a single one, like how come there hasn't been some kind of open source solution before where like everybody can kind of rally around it? Is it not that every company has different problems that may not fit for all this for a single solution?
The data platform space is very complex, and there are existing larger products that sort of address this problem. But there's not one like single database that there's no solution that just solves like this one problem. It's like if you want a paid solution that solves this thing, you have to buy something much bigger. Like you have to buy into like Databricks Delta Lake and get their whole solution.
So this one particular problem that you're solving is actually been solved by others, but you're saying that you can't just grab this one piece off. You have to get the whole thing in order to solve this one problem. Is that right?
Yeah. I'd also assert that nobody has solved it to this level of efficiency before.
So this is a good question. Like, how do you measure efficiency, right? I think you're measuring in different aspects, right? Because you make quite a few claims where you're talking about like millisecond replies or writes, that you can handle lots of writing. I believe also reading shouldn't be an issue. And like, how do you measure your efficiencies compared to others out there?
The main thing I'm thinking about is compute cost to actually run like the ingestion. So for instance, at Lyft, well, maybe I shouldn't say, but I had an estimate for the like internal cost that the company was spending on these tasks. And I felt that it's something that like a real solution could save a substantial amount of money on. So like, why not make this and have multiple companies reuse it?
Speaking of that, I mean, this is definitely something for companies, right? It's not really for individuals.
Right.
Okay, so you must have some type of model for keep working on this project. So, I mean, I believe you said 7 months, right? Working on this.
Mm-hmm.
And so how do you plan to, I don't know how to be less direct, but how do you plan to actually make money from this so that you can survive and keep going working on this?
So my plan right now is just to drive adoption. It is under a business source license that allows anyone to use it for free, as long as you're not selling it as a product itself. Like you can use it within your company as long as your company is not, a wrapper for it. And I'm an engineer, so on the business side of things, I'm a little bit slower, but the idea is that I would add this into like AWS Marketplace as a SaaS product, and that anyone could like just specify like, this is my configuration I want, and launch as a product.
So do you plan to monetize using AWS Marketplace then, at least to start paying off some cost?
Yes.
Is that your only way to monetize at the current moment, or you're still thinking about this?
I'm still thinking about this, but I think different cloud marketplaces are by far the easiest way to go for now.
And one more question about this is the license. It sounds similar to like things that like MongoDB are trying to do, where it's like, okay, you can use this, but I don't want places like AWS like selling our service and making money. Is that also the similar thought process that came into your mind?
Yeah, it is. And I kind of spent too long thinking about licenses a few months back. I think it kind of bugged me down. I actually talked to a lawyer about it because I was having trouble finding a license that really expressed what I wanted. Like I'd seen business source license, and my initial thoughts, I had some concerns. Like, what is this whole like change license thing? If it's going to turn into Apache 2.0 at some point, is that really what I want? Or like, will I have a chance to like change the license further down, or is it like set forever? And what alleviated my stress is knowing that like, okay, there are other companies out there that are changing their licenses. It doesn't affect their like previous code, but it affects all the code that they commit to like going forward. And like B, there are these like established players, at least somewhat established, like CockroachDB and stuff that are changing to this model. So I figured like it's too early to worry about this.
Yeah, but I do think it's really worth the time to take a look at the license because, like, yeah, you can change it, but there's definitely a lot of ceremony when it comes to changing it. Like, I think I've heard some people saying that they have to go back and chase every single committer who's committed code to their project and get them to sign something when you change it. Don't take it as the truth, but that's what I remember hearing in a podcast a while back. So I don't think there's such thing as spending too much time because, yeah, we're lucky that, of course, the later that you wait is the better, right? You have more examples, but I'm glad to hear that you thought about this and you actually talked to a lawyer because lawyer would definitely be the way to go. I'm curious about when you talk to a lawyer, did you talk to a lawyer who's actually very well versed in software licenses or just like a friend or something, or who'd you talk to?
I found this platform called UpCounsel, and I think the lawyer I talked to was experienced in this, but she was mainly trying to sell me on like having her write a custom license from like templates that she was familiar with. And that made me a bit uncomfortable because like I'd rather have a well-known license that like people understand. When you publish a Rust crate, for instance, it asks you like, what is your license? And if it doesn't conform to like one of the established codes that they have, then I don't think they even let you publish to crates.io.
Wow, that could make sense, right? I mean, I would love to hear back from whoever wrote this part of the code because it does sound pretty interesting, but I can understand if that is what they actually do. You can confirm this or you just think this? I'm curious.
Well, I definitely know that they insist on you having a license and listing one of the codes. But if you set your code to be like custom, I'm not sure that they let you publish. So someone will have to double check that. But like certainly the idea of like if someone's library depends on yours and yours is closed source with like vague terms to it, it makes it unclear if any dependencies on you will be able to run, right?
Yeah, that makes sense. Yeah, so maybe we can talk more about how PancakeDB actually works, right? So you have multiple different pieces, right? Including a core, the DB itself, and some kind of IDL. Like, can you talk more about the architecture of Pancake, which of course is probably what makes it so high performance, right?
Yeah, so in part thanks to Rust that it's so high performance. I knew from the start that I wanted to write this in Rust just from like what I'd been hearing about it, like how it helps ensure that your code is safe and that it's the best language you could have for a database. But what sort of convoluted this whole task, and one of the reasons why there are so many repos, is the fact that a lot of the big data tools are in JVM. So Spark is in JVM. And I wanted this common core that could like efficiently compress and decompress the data that you read, because internally the database needs to do that a lot. And when you read from Spark, you need to do that again. And Rust doesn't interop that well with JVM. Or it's possible. You have to use JNI, and that's what I ended up needing to do. But that was the impetus for I need a separate code generation library for my protobufs, and I'm going to use that in Java land and in Rust land, and I'm going to have a core library and use that through the JNI, like Java native interface for Spark. It got complicated.
So, but I don't see anything here in particular about the JNI is part of this Pancake Scala client. Is that what you're saying?
Oh, no. So Java native interface is how you can call into like system native code in the JVM.
Mm-hmm.
So normally JVM code can only run like JVM code. But if you have a binary on your system, like a dilib or whatever that you've compiled through C or Rust, the Oracle engineers, I guess, designed a way for you to interop on a memory level between the Java code and the dilib. So that's what the Java native interface does. It's like Java and native code.
Where's the JNI interface in PancakeDB, though?
So if you look at the Pancake Scala client, there's this subfolder called native, and that just contains a Rust lib that uses this special package. I don't remember what it's called. But basically, the special package will export your code in a way that the JNI can read. Oh, yeah. So the package is just called JNI. And on the Java side, you have to build these interfaces. So I have this native core Scala object that has all these like undefined methods. They just have this annotation that says @native. And on the Java side, in Scala, you run this command spt java h, and it makes a bunch of like C headers that tell you how your Rust functions need to be named and what their like input types need to be in order to interface correctly.
Yeah, I also seen that you're saying pub extern system instead of pub extern C. So for when you work with JNI, it has to be a system instead of C?
I don't know why this is. I just followed the examples for this part.
How is the experience between the interop between Java and Rust? Is it pretty seamless?
Once I got it working, it's pretty nice. One thing I am going to have to go back and redo eventually, though, is that right now all the Rust results will just be panics, basically. And I wish that the JNI would throw those as exceptions in the Java world. But instead, it panics in the Java world as well. So if your Java process calling into Rust code encounters a panic in the Rust code, that the whole Java thing dies. So I'm going to have to redo this to some extent, or just propagate the results instead of expecting them in the linking code.
So wait, you're saying if your Rust code panics, then your whole entire JVM will go down. Is that what I got from this?
Yep.
Okay, that makes some sense. I'm aware of a lot of other things a lot of other kind of interops doing the same thing.
Yeah.
Okay. And you compile this as a C dynamic lib instead of a static lib. Like, why do you choose to do C dynamic over static?
This is an area I don't know much about. I think it has something to do with the linking, but I don't want to say anything I don't understand.
Okay. So before this, you're working in different areas in machine learning or something with big data, right? So like, what was like your kind of experience and how did you get into big data and what kind of things have you been doing in there?
Yeah, I'll start with how I got into it, which is like I studied math and physics originally, and I interviewed at Wealthfront. I was considering between like grad school and Wealthfront or working in tech. And the guy who recruited me, or the manager who was like interested in hiring me, had all these claims about like, we need people to do like complicated statistics and machine learning here. And in data engineering, you'll get a chance to do that. And that turned out not to really be the case. So this won me over, in addition to the obvious fact that I'd be making money instead of paying more money in industry. But yeah, it turned out at Wealthfront that they really just needed data engineers to write like, these data pipelines that resemble SQL. So there's like Spark jobs and stuff like that, materialized views. So I got a good like year and a half of experience in that, and I actually enjoyed it a lot. So when I went to work at Hive, I was able to do actually more advanced machine learning stuff, but I ended up building their data platform as well because I had this experience, and built a big part of their, at least at the time, was their flagship product. It's called Mencio. It's like it just finds commercials in like raw television streams. So from those two experiences, I was like pretty bullish on Spark and other big data technologies, their ability to do batch processing, and that like it's really nice when you can change the logic that defines your outputs at any time. If all your pipelines are streaming and you want to go back and change historical data, it's rather difficult. But if you have a system that can do batch processing, it makes so much easier to change the logic whenever you need to.
What kind of things would you want to change, though? You're saying like you're manipulating the data, or you're just trying to make it more like basically cleaning up the data? Is that what you mean by changing it?
I mean, with the derived data. So a lot of companies will group their data into like immutable event data. So that stuff never changes, and derived data. So for instance, events could be like user clicks on the web page, an activity, and there will often be like pipelines that group these together into user sessions, like higher level information. So that would be derived information. You can never change the fact of like what a user clicked, but you can change how you interpret it. So these pipelines are often pretty dynamic at companies. Like we want to change our definition of a session because, an hour didn't make sense. People usually only spend 15 minutes on the web page, things like that.
Okay. I see what you're saying.
Yeah. I think I only addressed like one of the questions you asked in the last round.
No, that's fine. I find this is quite interesting. So PancakeDB can actually help with this problem, right? Because that's what I think I'm understanding.
Yep. So PancakeDB would be to ingest those immutable events. And then your batch processing can query both immutable data from PancakeDB, derived data from wherever you store that, and stitch it together into more derived data.
Now, we're saying PancakeDB, like, I can't help but think that PancakeDB is kind of like a SQLite, where it's like a binary that kind of runs there, or there's like a file that's kind of runs over there, and then you would just have multiple of these per kind of like derived data, right? So let's say like, maybe I'm concerned about like session, right? And I would have my derived data be all about session-based stuff. And another team may be concerned more about like, are we shipping enough stuff? Or like, like if I go, when the user clicks something, to when that package is delivered, is it actually being efficiently delivered? I don't know, I'm just kind of throwing arbitrary ideas out here. Like, are we looking at like, would that be multiple PancakeDB instances, or is it something like one PancakeDB with multiple databases inside there, like a Postgres or a MySQL, where we can kind of have multiple databases within one database engine?
That's an interesting question. It is meant to be as like a server. So this would run on, you would have one PancakeDB instance per company probably. Running in an embedded setting probably would not make as much sense for PancakeDB because you just wouldn't get the scale. Like if you had this running on a user's phone, it was like compacting the event data that they want to transmit to the server. You just wouldn't get a very compression ratio or anything like that because the data is so small.
Okay, so people would just take a separate server, run PancakeDB on it, just like you would for like an AWS. You have like a RDS, this kind of thing. Run it, start throwing ingestions at it, and then people would just say, okay, but you're actually sending derived data to it. Or sorry, not sending derived data. You're sending actual immutable data, and then you would take PancakeDB, and then from the immutable data, then you would be deriving data and also putting that within PancakeDB, right?
Probably not. So with derived data, like if you've gotten it through a batch processing system, it's already in like big chunks. You don't need to write it one row at a time. You can just like slap that onto S3 or anything, and PancakeDB doesn't really have any like value proposition for being better at storing like derived data because it already comes in these big chunks.
Okay. I had a feeling in my head that this was actually using derived data underneath, but okay, so it's using immutable data. So you're just sending all the immutable data, and then you'd use another tool like Spark to derive data from that immutable data. Is that right?
Yep, exactly.
Okay, now it's starting to come into my mind. So it's basically the first point of the data pipeline, right?
Exactly. It's like the best sink to write your events or immutable data or streams into.
Okay. Now it's starting to come together for me. Excuse me, I'm just a software engineer. I feel so lowly to data engineers when they talk about data. It's just too much math for me. But now I'm starting to understand.
There's very little math in data engineering. It's just a different subdomain, really.
Yeah, I think I had a discussion on another podcast talking to a guy that I forgot what the name of the product was, but their whole entire idea was like, so you want to bring data analysis or data engineering to software engineers. And they said the problem is that like, at least what I would equate it to is like making a cake, like all the ingredients for the recipe are there and the recipes are there, but you have to go out and find them. And then you have to understand like how to put them together. But if you've been doing this for a while, obviously you can do that kind of stuff. And so what they were trying to do is trying to make these like ready-made solutions. Like you just suck your data into there and you say, okay, I want to run this analysis on here. And they don't talk about the formulas and everything. They just say, okay, here's kind of like some finalized pieces, just connect and then you're done, so that you can get powerful analysis without actually having to dig into the math. I mean, still math to it, of course, right?
Yeah, I've been paying more attention to the space of like data engineering solutions since I quit Lyft. And I've been struck at like just how many companies are out there. I didn't realize to begin with. And every one of them seems to cover like a different range of subproblems, like some like a different vertical integration of like we solve this and this and this, and then the start and the end of the like substack that we solve. But when you look at their webpage, it all sounds the same. Like if you load up a new like data engineering startups webpage, it's just like we solve, making your data seamlessly available for your business intelligence. So even when I look at these companies, it takes me a while to figure out what's going on.
I think the biggest issue is that the people who actually hold the credit card or hold the bank book are the ones that maybe don't quite understand the tool. So you have to kind of make it into a lingo that people can understand. So it's like, we empower your business. Okay, that sounds good. That's what I want. And then they will purchase it, right?
Yeah.
I mean, try to explain event ingestion to somebody who just wants to know, are we making money and do we need to make changes to the website? I don't think they're going to be able to look at PancakeDB and understand if this is going to be helpful or not.
Yeah, it's a big challenge.
Okay. Yeah, so PancakeDB, where did the name come from? Like it's a name that makes me kind of hungry, actually, because it's breakfast time over here.
Yeah, I was thinking about like what's a food that you can stack down in rows and you can eat in columns, and I couldn't think of a better one than pancakes. Not everyone eats their pancakes this way, but like you can put them in a stack and then you can take a slice out of all the pancakes and eat that. That's one reason I came up. I like that idea. Another one was that a stack of pancakes looks like the database logo, like what you see in all the flow charts, where data goes into the database and it's like some round cylinders on top of each other. It looks just like pancakes. And the last thing that made sense to me was someone mentioned this to me later. It wasn't originally my idea, but to pancake something is to make it like small and compressed. And one of the selling points of PancakeDB is it has good compression.
So did the name come first or did the project come first?
The project. And at first for a little while, I was like, names don't matter, so I'll call it UglyDB. And then I thought, I guess the pancake name occurred to me, and I was like, no, that's a good name. I should go with that instead.
I just feel like UglyDB would probably set you back, to be honest. It just sounds like something I wouldn't want to use.
Yeah, exactly.
Okay, so let's say I'm a software engineer, right? Because I think most data engineering, there has to be a software engineer to kind of implement like the ingestion of data, right? So if I'm a software engineer, I got to implement this thing. Like, how would you recommend somebody start to implement this into their stack?
So at the moment, the best way is you would just like start up an EC2 instance with like an EBS drive on it. You'd mount that EBS drive, you'd download the PancakeDB repo, run the Docker image, and that would be that. You'd have a server running. So I understand this is like not the simplest process. It will change in the future.
Okay, but what you just said only covers like how to actually turn it on and start running it. Like, like what would you recommend as a way to start to add it in, right? Because should I just, as like when a user clicks something, I just have something in my backend which will just send a request to it? Or like, is there any kind of things that you think, or some tricks or something that maybe people should know when they want to implement something? Like if I'm certain kinds of events or certain kinds of things maybe we should be aware about?
Yeah, so if you're starting from zero, then all you have to do is then start using like a PancakeDB client in your backend service, and you can just have it write directly to PancakeDB. And the write response times are so fast that it's comparable, or this maybe even faster, I'm not sure, than writing to like a queuing system like Kafka or RabbitMQ. If you have a more complicated architecture, or you're already writing your events to like a streaming system like Kafka or RabbitMQ, then right now you'd have to set up like another like sort of pass-through service that just reads from those streams and writes to PancakeDB.
Okay.
And on the other side, once you have the data written to PancakeDB, you can use a Spark cluster. So setting up Spark is its own thing. I've actually written a couple blog posts about setting up Spark on Mesos. You're using that resource manager. But you can run Spark locally. So that's probably the easiest way if you're starting from absolutely zero.
So all this data, it's actually immutable. So is there anything protecting people from kind of going back and changing things? Or Like it's just basically append only, right?
It's append and delete only. Yep. So you can't like modify a row, but you can delete in case like you added erroneous data.
Even if I wanted to say like, because I'm just trying to think like what usually happens is that usually you have some, at least in my mind, is that you have some events that you triggered, and then you probably want to maybe augment those events with some additional metadata. So you could never do something like that. That would be part of derived data, right?
Yeah. So typically like your schemas evolve where if you add a column, like the value for that column is null in all the pre-existing data. And then your downstream services have to know like what that null value means, right? Like, is that a 0 or a 1 or whatever?
Can I ask you something from just a general curiosity, like somebody who's into Rust as you? Why is it that nobody creates something Spark-like in Rust, at least that I know of? Because I just find it so strange that Java has such a big market in here, because when I think about Java, it's just like a memory-hungry thing. And when you're processing lots of data, that obviously is going to take lots of memory. So it just doesn't really make sense for something that should be efficient to be using Java.
Yeah, this is an interesting question, and I think you should hold out hope. So, for instance, Databricks, one of their founders was like the original guy behind Spark, and now they're writing another framework that's in C. So not Rust, but like they could port it to Rust eventually, hopefully. And I think there is momentum in that direction. One of the weird things about Spark is that it does some code generation at runtime, which is an important thing to optimize like each stage of your Spark application, because sometimes it doesn't know until you've passed in the parameters what the most efficient way to run this loop on millions and millions of rows of data is. And in Java, it's kind of weird. Like they're doing these, just got like big pieces of Java code in strings, and they do string interpolation to replace parts of that string, and then they call into the compiler again to build that code. But I think in Rust, they could do something more like, they wouldn't be able to do like actual runtime code generation, but they could do something more like macros or find some other way to avoid duplicating many cases of the code manually.
I just can't help but think there has to be a better way to do it with Rust. I mean, there's just no garbage collector. There's no, you have a JIT, but at the same time, like you've basically already JITted. I mean, you have AOT, which should be still okay. I mean, I understand that JIT could probably do a little bit better once you see the data.
I've run some like dummy examples, like not exactly what would happen in Spark under the hood, but like cases of like, I've got like 5 different Boolean flags, and each one should have a different, like each combination of Booleans should have a different like optimal loop, and see like how does the JIT do when you exactly specify the 5 Booleans and then run it a million times. And in some simple cases, the JIT will figure it out and run the more efficient piece of code that's like 10 times faster. But the more complicated it is, the less likely it succeeds.
Yeah, that makes sense. Yeah, so I want to talk more about like, I think I kind of want to wrap up this session to talk more about like, when you're working in other companies, right? What was your primary choice of language? And I'm guessing it's probably Java or Scala, because I see you wrote lots of Scala, or Python, or maybe C or C++. Like, what was your kind of primary tool when you kind of first started off?
So previously, my favorite language was Scala since like 2016. I'm not a big fan of Python for like real software engineering projects. It seems like it's nice that everybody knows it, but you have to slap on so many things to make it like software engineering worthy. Like you have to have MyPy, and you have to work with its like annoying like VM system, and like build times are slow, code runs slow. So, but I think I would now say Rust is my favorite language.
Well, that was actually going to be my follow-up question. Is it your favorite language, but like, what brought you to Rust if you've already kind of been working with things in the past, right? What kind of made you step out and take a look at something else?
The main thing was that just word of mouth. I'd heard from some friends that they were loving Rust, and I knew it would be good for these like slightly lower level pieces of code that you need to be well optimized, and for code safety. So I was thinking about building a database, and that's like, well, those are all the things I need.
So hearing from word of mouth from people around you, right? That's what made you take a look at it? Is that what I understand?
Yep. Mm-hmm.
Okay. So after you took a look at it, obviously you built PancakeDB. Like, is there any regrets, or is it 100% smooth sailing? Like, I think you could say a couple of good things. I mean, there's a reason why we're on this podcast, right? But I don't want to say too much good stuff. I want to also hear, is there anything that was maybe not so good?
I did a lot of early refactors around like, how do I want to deal with errors? That was something pretty hard for me to figure out in the Rust ecosystem. Like, should I be using anyhow, or should I be like making my own enums for all the different error types I could handle? Like, why can't we, for those crates that use their own like enums for all the error types, like, why can't we just have like a common error type? Why does every crate make its own? So that part was rather frustrating. I think one of the other difficulties was figuring out lifetimes. So the borrow checker mostly like made sense to me after a little while, but I've been working to like avoid needing to deal with like lifetime parameters as much as possible, because sometimes it's just like really hard to convince the compiler that one variable will not outlive the scope it's in.
Yeah, I think that's probably one of my biggest issues is like, I actually worry about that. I don't worry about the safety, all these other things, but I worry that I have to actually do the lifetime syntax and actually think about this, which I know it's good to think about it, but yeah, it does take some time to think about it and get it correct, right? I mean, do you feel more comfortable about it now?
Yeah, I feel a bit more comfortable, but like still, I mostly would only use it for like simple functions where you just you pass in a pointer, and the function only has to know that the pointer lives as long as function call, like that scope. But I look at the definition of like mutexes and read-write locks, and like they've got lifetime parameters pointing to some semaphore, and I just don't understand how those things satisfy Rust. So there's still stuff I have to learn.
Yeah, I know what you mean. Rust is really big language. Not really a big language, but it's deep. Yeah, that's the way to say it. It's definitely deep. Yeah, I mean, I think I don't have anything else before I have a couple of wrap-up questions. Is there anything that you want to kind of say, like maybe people come check out your project or looking for help to kind of work on it or anything like that? Any kind of shout-outs?
Yeah, if you're curious about event ingestion or just like a cool Rust project, go to PancakeDB.com. You can join the Discord. Let me know if you're interested in contributing or if this could make your life easier. There's still a lot of development to do. So at this time, I'm especially looking for collaborators or partners who might help me like figure out the best direction to go in from here.
Yeah, I think my last question is like somebody who has spent quite a bit of time digging into Rust, and you already stated kind of things that you're not so happy about, but I think overall you're pretty happy with using Rust and you're pretty happy with your choice. Like, is there any kind of advice that you would give to people who are kind of getting into Rust still? Like maybe don't fight the borrow checker, or take your time in reading it, or things like that. Do you have any kind of advice you'd give?
Yeah, so one thing I encountered specifically because it came from like such a Scala background is sometimes you really want like an abstract class. You want a piece of like something that defines both data members and logic on those data members, but yet is abstract or has some like trait implementation that's missing. And in Rust, the way to do that is by making a generic struct that has a concrete implementation depending on its data members, but where that generic type specifies the missing logic. So that was one thing that caught me up. Another one is like with the types in like Scala, it's really easy to pass around just whatever types you want. You can say like, this argument has to be a trait or like some combination of traits. And in Rust, you can still do that. It just takes a bit more syntax. But you do have to think about like, is this something that's generic or is this something that's dynamic at runtime? And that matters because the compiler will be able to optimize better if it's actually generic, if you know the type in all instances the code is called in or not.
Yeah, that's a good point. I just recently started looking more at this, and I definitely, if you can go generic, that's definitely the way to go. Like you said, you can get a lot more optimizations out of it.
Yeah, if you can.
Cool. Is there anything else you want to say before we sign off?
Thanks for having me, Alan.
Thanks for coming on. I appreciate you coming on so quickly. So again, thanks for your time. We may have you come back after kind of, post-mortem, or maybe post-mortem is kind of a negative thing to say. After, sometime to see how it's going, right? Because I'm sure as more and more companies use as more and more people use PancakeDB, and as time goes on, you're going to be making further and further adjustments. So we'll see how it goes.
Yeah, thank you.
Thanks.